All right, guys, let's see what you did. I hope you made this a you try and you tried it out, or you can go ahead and try it now, hit pause. But let's see what we get. So before we start, again, I'm going to draw my toolbox again. Okay, it's so important to keep in mind the equations we're going to use. So we have x squared plus y squared equals r squared. We have x equals r cosine theta and y equals r sine theta. So let's go ahead and try this out. We also have tangent theta equals y over x in case we see that. Okay, so let's see. Y equals x squared. I can substitute y with r sine theta, and I can substitute x with r cosine theta. So I'm going to go ahead and do that. So on the left-hand side, I have r sine theta, and on the right-hand side, I have r cosine theta, all of that squared, which is just r squared cosine theta. And on the left-hand side, I have r sine theta. Okay, so usually what you want to do for these polar equations is to solve for r. So the tip is to solve for r or r squared. Because let's say it's a matching, you want to be able to match the correct your whatever simplified form you have to what's given. Or let's say this is something you're going to use later on in calculus, you'll probably be given an r or an r squared, to either graph or when you get to calculus to find the area between curves and things like that. Okay, so we want to get this to r or r squared. Okay, so what can I do? Well, I can simplify what I have. Okay, so I can normally we would move everything to one side and set equal to 0 and then factor and simplify. But in this case, I can eliminate an r, and if I do that, I get rid of the possibility of r being 0. However, that's not as important here as when you're in the rectangular plane. So when you're in polar, you can't do this. Okay, so then I have, but I don't want to get used to bad habits. So let's just move everything to one side. Oops, and I forgot the square there. Thank you for letting me know. Thank you, guys. I know you did. You called it, a few of you. Okay, so let me subtract that, or let me get everything on one side. That equals 0. Factor out an r. So I have r cosine square theta minus sine theta equal to 0. So either r equals 0 or r cosine square theta is equal to sine theta, right? Which is the same thing as r is equal to sine theta over cosine square theta, which is tangent over cosine theta, or tangent secant theta. So if this were some sort of matching, this is the most simplified form that you would get. Because r equals 0, that's not an equation, that's just the point. And, that's not what we're looking for here. Okay, so that's part A. Part B, let's see, we have 2xy equals 1. So back to our toolbox. Instead of x, I can replace that with r cosine theta. And instead of y, r sine theta. And that's equal to 1. So this is 2r squared sine theta cosine theta equals 1. Okay, which we know this is, how can I simplify this? I have r squared times, do you see it? Double angle formula. sine of 2 theta equal to 1, which means r squared is equal to, if I divide both sides by sine of 2 theta, I have r squared equals cosecant of 2 theta. And if this was a matching, this is what I would want. Okay, now let's say this is a quiz and it's just convert, and I don't give you any instructions further than just convert to polar form. Then if you left it unsimplified, that would be just fine. But let's say this is some sort of matching, and I give you the most simplified form and I ask you to match, then you would, try to simplify as much as possible to get your equation to look like my equation. Okay. All right, that is all for today. You have a 10.6 web assign due next Wednesday, which I think a week is more than enough time to get this done. See you later.